Welcome to a completely different world of data management. We are entering the realm of NoSQL databases with MongoDB. MongoDB is the leading document database, offering flexibility and scalability that relational databases, like MySQL and PostgreSQL, may not easily match. 1. What is NoSQL and MongoDB? NoSQL stands for Not Only SQL. These databases handle unstructured or semi-structured data and do not rely on fixed table schemas. MongoDB specifically stores data in flexible JSON-like structures called documents. 2. Core concepts, documents, and collections. Think of MongoDB concepts by comparing them to relational databases. A document is the equivalent of a row in a table. A document is simply a map of keys and values, similar to a Python dictionary. A collection is the equivalent of a table, holding a group of related documents. Crucially, documents in the same collection do not have to share the same fields, making the schema highly flexible. Here is an example of a MongoDB document. Notice the nested fields, like supplier, and the list of values, tag. This kind of complex data can be stored naturally within a single document, simplifying data access. 3. Section roadmap. To work with MongoDB, we will first install the server. Then we will explore the MongoDB console before installing the Python connector, pymongo. Finally, we will cover all the CRUD operations using the pymongo API. To summarize, we are ready to dive into the flexible world of MongoDB. Our next lecture 30.02, Install Mongo. See you there. Welcome back. Before connecting from Python, let us spend a few minutes in the MongoDB shell. This helps us understand the structure of MongoDB commands, which are very different from SQL. 1. Accessing the Mongo SH. Two. Basic database commands. The command to view existing databases is show DBS. To switch to or create a new database, you use the used command. Let us switch to a new database called MongoDB_Python, which MongoDB creates if it does not exist. Three. Inserting a document. To insert data, we access the current database using the db variable, then specify the collection name, for example, db.customers, and call the insert1 method. The argument is the document itself, written in JSON format. For finding data. To perform a read operation, we use the find method on the collection, calling db.customers.find, parenthesis without any arguments retrieves all documents in that collection. We now have a basic understanding of MongoDB's syntax. To summarize, you now have a foundational understanding of MongoDB commands. Next, we install the necessary Python connector so we can execute these types of commands directly from our Python scripts. Our next lecture 30.04, Install pymongo. See you there. Welcome back. The MongoDB server is running, and you have seen the Mongo shell. Now, let us install the Python library we will use to connect to and interact with MongoDB, pymongo. 1. Introducing pymongo. pymongo is the official and recommended Python driver for MongoDB. Its primary job is seamless translation. It automatically converts Python dictionaries into BSON, or binary JSON, format, which is how MongoDB stores its documents. This makes working with MongoDB feel very natural in Python. 2. Installation command. Open your terminal and use the pip3 command. There is no special binary version needed this time. Simply type pip3 install pymongo and let it finish the installation. 3. Verifying the installation. Just like any other library, you verify the installation by running a small script or entering the Python interpreter and attempting to import pymongo. If the import passes without error, you are ready to connect to the MongoDB server. To summarize, the bridge between Python and MongoDB is complete. Our next lecture 30.05, PI walkthrough. See you there. Welcome back. Before we start inserting data, we must understand the three core objects in the pymongo API: the client, the database, and the collection. These objects form a clear hierarchy that defines how we interact with MongoDB. 1. The Mongo client is the top-level object. It is responsible for establishing and managing the connection to your MongoDB server. We create an instance of Mongo client by providing the server's URI or URL, which for our local installation is the default address. The code uses Mongo client and the URI string. Once this line executes, the client is ready to access databases. Note that MongoDB does not require explicit connection closing, but it is good practice. 2. Accessing the database. The second level is the database. Unlike SQL databases, MongoDB databases do not need to be created upfront. They are created automatically when you first insert data into them. We access a database object from the client using simple dictionary-style bracket notation or dot notation. Both dot notation, client.mongodb_python, and bracket notation, client bracket quote mongodb_python quote bracket, retrieve the database object. We will store this in the DB variable. 3. Accessing the collection. The third level is the collection, which holds the documents. We access a collection object from the database object using the same dictionary style or dot notation. This is the object where we will execute all our CRUD methods, like insert1 and find. We will be working primarily with this collection object in the upcoming lessons. To summarize, you understand the pymongo API structure. We are now ready to perform our first write operation. Our next lecture 30.06, insert 1. See you there. Welcome back. Having set up the pymongo connection hierarchy, we can now perform our first CRUD operation, create, specifically inserting a single document using the insert_1 method. This is where we see the Python dictionary truly shine as a MongoDB document. 1. Establishing the connection and collection. We start by recreating the client, database, and collection objects, targeting the customer's collection within our MongoDB_Python database. 2. Defining the document. Remember, a MongoDB document is just a Python dictionary. We will create a new customer record. Notice that we can easily include complex data types, like a list of favorite foods or nested address details, right in the same dictionary. We define our customer details in the dictionary name customer_document. 3. Executing insert_one. We call the insert_one method on our collection object and pass the dictionary. The operation returns an insert_one result object. MongoDB automatically generates a unique identifier, the _ID, for this new document, and we can access it from the result object. We print the insert_result inserted_ID to confirm the creation of the document. To summarize, you have successfully created your first MongoDB document from Python. Our next lecture 30.07, Insert Many. See you there. Welcome back. While insert_one is useful, applications often need to store many records efficiently. This is where the insert_many method comes in. It allows us to insert multiple documents with a single call to MongoDB. 1. Defining multiple documents. To use insert_many, we must provide a list of dictionaries. Notice the flexibility here. The first document has a phone field, but the second does not. MongoDB's flexible schema allows this without any issues. We define a list name, customer_list, containing 3 unique customer dictionaries. 2. Executing insert_many. We call the insert_many method on our collection object and pass the list of documents. The operation returns an insert_many result object, which is slightly different from the insert_one result. The insert_result.inserted_IDs attribute now holds a list of the unique _ID values generated by MongoDB for all 3 new documents. 3. The _ID field generation. If you do not explicitly include the _ID field in your Python dictionary, MongoDB automatically generates a unique object ID for each document, which is what happened here. If you choose to supply your own unique identifier, MongoDB will use it instead, provided it does not already exist. To summarize, we can now efficiently insert one or many documents into MongoDB. Our next lecture 30.08. Read. See you there. Welcome back. We have successfully created several documents. Now it is time for the most frequent database operation, reading data. In MongoDB, this is handled primarily by 2 methods, find_one and find. 1. Retrieving a single document with find_one. To fetch just one document that matches a specific criterion, we use find_one. The method accepts a Python dictionary as its first argument, which serves as the query filter. We want to find the customer whose name is Charlie. The find_one method returns a single matching Python dictionary or none if no match is found. Note that we do not use the cursor concept here, because it is only one item. 2. Retrieving multiple documents with find. To retrieve all documents that match a filter, we use the find method. This method returns a cursor object. To get the data, we must iterate over the cursor similar to PostgreSQL, or convert it to a list. The query dictionary is active:true. The find method gives us the cursor, _cursor, which we iterate over using a for loop to process each document. 3. Retrieving all documents. To get every document in the collection, simply call the find method without any arguments. This is the MongoDB equivalent of select star from table in SQL. We call collection.find parenthesis. To summarize, you can now insert and read data from MongoDB. Our next lecture 30.09. Update. See you there. Welcome back. We have covered create and read operations. Now we focus on update. The update operation in MongoDB requires a different approach from SQL, relying on update operators to safely modify fields without replacing the entire document. 1. The structure of an update operation. An update method, such as update_1, always takes at least 2 arguments. First, the query filter to select which document to update, and second, the update dictionary, which uses a special operator like $set. The $set operator is the most common, used to set the value of a specific field. Without an operator, MongoDB may try to replace the entire document. 2. Using update_1. Let us update Eve's city from Boston to New York and change her active status to false. We filter by name and use $set for the modification. Update_1 returns an update result object. We can check matched_count to see how many documents fit the query, and modified_count to see how many were actually changed. 3. Using update_many. If we want to update multiple documents that share a common attribute, we use update_many. Let us set all inactive customers to be in the city of Dallas. We only specify the query active:false. Update_many will apply the city change to all documents matching this filter. To summarize, you can now modify data in MongoDB. We have one operation left: delete. Our next lecture 30.10. Delete. See you there. Welcome back. We have reached the final CRUD operation for MongoDB. Delete. Just like with update, MongoDB provides methods to delete a single document or multiple documents based on a query filter. This is the simplest operation, but you must be careful with your filter. 1. Deleting a single document with delete_1. The delete_1 method requires only one argument: the query filter dictionary. We use this method when we know only one document should be removed. Let us delete the customer named Bob. The method returns a delete result object. The key attribute to check is deleted_count, which will be 1 if a document was successfully deleted. 2. Deleting multiple documents with delete_many. To remove all documents matching a specific condition, we use delete_many. Let us remove all customers whose active status is false. The deleted underscore count will now reflect the total number of documents that were removed by the operation, which may be greater than 1. 3. Caution: deleting all documents. If you pass an empty dictionary to delete_many, MongoDB will delete every single document in the collection. Always make sure your filter is correct to avoid massive data loss. To summarize, congratulations! You have successfully learned CRUD operations for both SQL and NoSQL databases. This wraps up our section on MongoDB. In the next section, we shift focus to a crucial development skill: debugging. Our next lecture 31.01. Use case. See you there.